Students, this is question number 11. We are given f of x to be equal to x squared positive 3, x is greater than 0, and g of x is 2x positive 1, x is greater than negative 1 over 2. Now, the first part of the question is we have to find fgx. Let's do this first part. Now, solution fgx is rewritten as f of g of x, which is going to be f of g of x is 2x positive 1. You substitute that over there, so that's going to be 2x positive 1, the whole squared positive 3. So this is going to be fg of x. Now the next step wants us to find fg inverse of x. Right, so we need to get the inverse of for this. I'm going to take this as y. Now I'm going to rewrite this as y negative 3 is equal to 2x positive 1 the whole squared. Then I'll take square root on both sides. That would give me square root of y negative 3 is equal to 2x positive 1. Now let me use this base. So I'm going to move this 1 to that side. So that would give me root of y negative 3 negative 1 is equal to 2x. And one important component is we have to change all the x to y and y to x. So that means this is going to be root of x negative 3 negative 1 is equal to 2 times y. And from here y will be equal to 1 over 2 times of square root of x negative 3 negative 1. Now what is this? This is exactly my fg inverse of x. So I'm going to write that down here. So this is equal to 1 over 2 times square root of x negative 3 negative 1. Okay, now we are asked to find the domain. Now clearly for the domain, you see x is actually inside the square root. So all values, the domain would be all values of x strictly greater than 3. That will be the solution. If it goes below that, then it will become undefined. So having got this, let's move on to the next part of the question. So we have completed the two parts A and B. We got part C. Now the part C is as follows. We are asked to solve fg of x negative 3 is equal to gf of x. Okay, now fg of x, we have already got fg of x. Fg of x is 2x positive 1 raised to the power of 2 positive 3. 2x positive 1 raised to the power of 3 positive 3 is fg of x. Now we have to find, with f of x being x squared positive 3 and g of x is 2x positive 1, we need to get gf of x. This is nothing but g of f of x, which is nothing but g of f of x is nothing but x squared positive 3. So you substitute here is going to be 2 times of x squared positive 3 positive 1. So this is g fx. Now the question states that, okay, if I were to take this as say sum 3, we need to solve that. So using 3 we have now. So what do we have now? fg of x is 2x positive 1 whole squared positive 3 negative 3 g f of x, that's 2 times of x squared positive 3 positive 1. Negative positive goes off, you expand this, you get 4x squared. 4x positive 1 is equal to 2 times x squared positive 6 positive 1. You add these two things, you get 2x squared positive 7. You get 4x squared positive 4x positive 1. You bring everything to the left, you get 4x squared minus 2x squared positive 4x positive 1 negative 7 is equal to 0. You add these two, you get 2x squared, positive 4x. You add these two, you get negative 6 is equal to 0. You divide by 2 both sides. You get x squared positive 2x negative 3 is equal to 0. Now you have to get a negative 3 and a 2. So what I'm going to do, I'm going to say 3 added with negative 1 will give you 2. 3 times negative 1 will give you negative 3. So this is going to be x positive 3 times x negative 1 is equal to 0. X into x squared, this is 3x and this is x, negative x, so you get 2x and negative 3, fair enough. So from here, x positive 3 is equal to 0, x negative 1 is equal to 0, x is equal to negative 3 and x is equal to 1. But we cannot take this value, right? So we drop this because of the restriction placed by the domain. So therefore x is equal to 1 is the solution.